If you were to drill straight down into Mars, what would you find? NASA's Martian lander called InSight detected 480 of these Marsquakes in 2020 alone. Luckily, there isn't much out there to damage. For us, these Marsquakes are a good thing. They create seismic waves that our scientists can study. And based on these studies, they can theorize about the Martian interior. But you and I would be doing this the hard way. We would drill through Mars to see what secrets it holds inside. If you started drilling through the reddish, iron oxide abundant surface layer of Mars, the first thing you'd discover is that the interior is not so red. But don't be surprised. In 2012, NASA sent the Curiosity rover to Mars. It landed about 3,700 kilometers, 2,300 miles, from the Jezero crater. Curiosity discovered that the layer beneath the surface of Mars is slate blue. That's because it contains high levels of silicon. And as you drill, you should continue to expect the unexpected. The next discovery you'd make is that the crust layer on Mars is thinner than the one on Earth. Remember InSight? This little lander indicated that the Martian crust is only around 20 or 37 kilometers, 12 to 23 miles, thick. Compare that to the Earth's crust, which is approximately 40 to 50 kilometers, 25 to 31 miles, thick under the continents. If water still exists in liquid form on Mars, it could be several kilometers inside this crust. And there are radioactive elements in the liquid mantle below the crust. These elements release geothermal heat through their decay. And it should be enough heat to melt thick sheets of subsurface ice. This geothermal heat could be why there was liquid water on Mars 4 billion years ago, even though the surface temperatures were below freezing. But enough theory, let's keep drilling. Boring through Mars would be even harder than drilling through Earth. The deepest we've ever drilled on Earth was 12.2 kilometers, 7.6 miles, into its crust. And that came with high budget costs, technical difficulties and plenty of bad luck. But on Mars, this would be an unimaginably tricky endeavor. The InSight lander tried drilling, but it encountered unexpected soil properties. The drill probe was trying to go 5 meters, 16 feet, deep but could only go a fraction of the distance before popping out. Then there was Curiosity. It experienced a mechanical error. The drill feed mechanism that was supposed to move the drill bit forward wasn't moving when commanded. Luckily, scientists designed a new, more human form of Martian drilling. Now, the rover uses the force of its robotic arm to push the drill bit into the surface as it spins. But don't get your hopes high about reaching the mantle of Mars too soon. It took Curiosity the entire day to drill a mere 5 centimeters, 2 hole. Based on that, going 5 kilometers, 3 miles, down would take up to 300 years. And you'd need a bigger drill. There's still so much we have to learn about Mars. But maybe drilling isn't the most effective way to do it. Especially since we haven't gotten very far into the crust of our own planet.